Hello guys. So today we'll be talking about deep learning. So do any of you have any idea what deep learning is? I'll explain it. So computers making decision where decision criteria do not have to be defined or specified or guided. So what does deep learning actually mean? So it refers to the depth of layers in the neural network. A neural network with more than three layers, including the output and input layer, and this can be considered a deep learning algorithm. But yesterday also we heard about neural networks, right? What is the difference actually? Let's think about what is the difference between machine learning and deep learning first. As we did yesterday, we were doing pre-processing and other tasks like dimensionality reduction, right? So this makes our work very hard when we are dealing with large amounts of data. So we use deep learning in that case because deep learning automates this pre-processing, dimensionality reduction, and also it gives a much higher accuracy. Now, why is that? Why does deep learning give a much better accuracy? The main reason for that is in comparison to machine learning, which takes data from the input layer and gives it to the output layer, we go from also do a back propagation in which we go from the output to the input layer. What this helps is it helps us correct the biases and the weights using which it can correct itself, like where is it having the error and can give us a better accuracy. Now you understand what deep learning is. So can you tell me like where have you seen deep learning being used recently? Any idea? Okay, so then I'll only tell we can see deep learning in daily life in Google search, right? So Google search also uses Google translation and self-driving cars, guys. How can we forget that? We all are very interested and deeply desire India to have self-driving cars, right? Also, these are used in catching frauds. So deep learning can catch any patterns which indicate some kind of financial frauds. Also, it analyzes audio and sound, so it can tell like if there's any threat. So it can be used in threat analysis and many more. Now let's study about the architecture and different frameworks we can use in deep learning.
Yeah. So coming to the different frameworks and architectures that we can use to develop our deep learning models. So few of them, as mentioned here, are TensorFlow, PyTorch, Keras, MaxNet, etc. So MXNet, sorry, etc. So I'll be talking about TensorFlow, PyTorch, Keras, and MXNet. So firstly, TensorFlow is a powerful engine that's developed by Google. It's very flexible and is very efficient when you're doing deep learning architecture models, and it helps not only with the small complexity models but also with large complex models. It runs very well on GPUs and hardware well, so it's most likely used by researchers. Next, coming to PyTorch. PyTorch is developed by Google, so it is also a deep learning framework which is supported for making deep learning models in architecture where you can perform even simple and complex algorithms. Same goes with Keras. Keras is a deep learning neural network library that is under TensorFlow. It works basically on TensorFlow on Microsoft Cognitive Toolkit and Theano. Next, coming to the different architectures that we have. So first, let's go with feed-forward neural networks. So basically, in this, the neurons that are connected are not in a cycle. So the information flows from one input to the output in a like each layer. When the data is transferred from each layer, it will learn and will pass on to the next layer till it goes to the output. Next, coming to recurrent neural networks or RNNs. So in this, basically, the information that is passed on from it's also a type of a neural network. The information that is passed on, it learns from what happened before and then predicts the next value based on today's value and the previous one. Next, coming to transformers. So transformers are use self-attention mechanisms where they deal with large data sets, and they focus on relevant information from the data and make predictions that account for variations across different factors. Next, CNNs, as we talked about yesterday, CNNs are also learned to detect specific features from the different layers that are there. And Each layer of the CNN learns to detect few features and then passed on to the next one to learn a different feature till we get the result or the prediction. Then autoencoders are a type of neural networks for unsupervised learning. They consist of basically two parts, encoder and a decoder. They are trained to reconstruct the input data, that is, they compress the data and they analyze after the compression instead of looking at the whole data. Then coming to GANs, I'll give a brief overview because Kavya will be covering it. Then GANs are basically they consist of two networks. One is the generator and the discriminator, where the generator creates new samples and the discriminator evaluates the authenticity of those samples, and they make each other better by evaluating. So over to Manaswini for covering Gen AI.
Thank you, Yagnishri. Introduction to Gen AI. Gen AI sounds very Gen Z and sounds very cool. Next evolution of artificial intelligence. We can say it is the next step to artificial intelligence that is being used in today's world by every single one of us. Previously, we used to say that, yeah, we have to go search it in the Google. We have to, go to the search bar, just search there. Yeah, but now it has changed. Ask Bard. Come on. If you have a question, coding question, go ahead, ask Bard or ChatGPT. Artificial intelligence has taken over, and Gen AI can be defined as the next step of it. And defining it is the convergence of advanced AI technologies and human-like cognitive abilities. Human-like. The word human-like, if broken, means that it has to take decisions and it should have the decision-making skills like a human does. And it combines deep learning, natural language processing, and reasoning to mimic human intelligence. Mimic human intelligence. We are seeing AI robots in today's world coming up, answering questions better than a normal human can. And Gen AI is characterized by its ability to understand context, learn from experience. This is done by all the deep learning, natural language processing techniques and algorithms that we use in our day-to-day life. And it adapts to dynamic environments. Everything is dynamic today. Today, we don't like something and we want to change it the next day. We can't keep it static. It has to be changing. And yeah, Gen AI is something that adapts to everything. Moving on, key features of Gen AI. Human-like understanding, as I said. For a model to understand something like a human, we have to train it in such a way that every single decision is very accurate, very precise. Adaptive learning, meaning it has to learn from its previous choices. Rather than learning from textbooks, it should learn from day-to-day changing environments. Ethical decision making. Decision making, of course, has to be ethical. We know that we can't get answers to crack a firewall of a very secure banking website. So Gen AI should have its own ethical decision making, telling that I can't help you with this, but I can help you with this. And seamless integration, of course, it should be in a position where it can be integrated with anything. We are still in the en route to that anything seamless integration. We can see an application of Gen AI or one of the most used fields. GANs will be covered by Kavya.
So now I'll be talking about GANs. So anyone here knows what are GANs used for? So GANs is nothing but generative adversarial networks. So by name, anyone can tell what it does. Okay, so now let's divide the name. So G is nothing but generative. That itself tells that it generates some data. So coming to adversarial. So adversarial means a competition. So I'll tell what competition is it now in soon. So coming to network, it is a part of a neural network and comes under deep learning. So why GANs come under deep learning? So as Abhinav has explained, the deep learn so GANs itself learns the biases, weights on itself. So what is the difference between the GANs, I mean the neural network used in the GANs and the neural networks? So there are something called loss functions. So that is how it is different from any neural network and the generative AI, which can do the self attention by itself. So now we'll talk about the architecture of the GAN. So basically, GAN consists of a generator and discriminator as Agna told. So what exactly it does? So generator generates the sample of data, and the discriminator will tell if it's the data given is real or fake. So coming to GANs, what are its applications? Where is it used? So any one of you can tell. Already I have told that what is GAN. So anywhere you have seen in any industry recently a new image generations were coming. Anyone? Yes, yes. So it is used in image generation, video generation, and not only generation. If any data is there to find the detection, also GANs are used. And how it is used only because of the self-attention the self-attention power GAN has. So coming to GANs, what actually the generator and discriminator do, why it is called adversarial, and why did I call it competition? So now let's consider our generator as a thief who is trying to create some fake data, and let's consider our discriminator as the police who wants to find if it is who is like creating fake data. So now, how does it exactly work is we will see in the next one. So here I'm showing the architecture of the GAN. It is a simple generative adversarial network. You can see here we are showing the image as the data. So I'm talking about the data, right? I had told in the last session that what type of data neural networks takes. So what type of data do you think GANs can take? Anyone? Yes, images and anything else. So can take any type of data until now, like images, uh, videos, text, and numerical. And currently, recent GANs were even able to take signals, signal processing, and signals also as a data, and that is under more research. So coming to this architecture, we are seeing the images. So here, first, what we'll be doing is from generator will be generating images. So it can be a random noise, like a random vector it is generating. So and it can start from the pixels, like random pixels on the image. So that it will be generating, and it will be sending it to the discriminator. So discriminator will be telling if it is real or fake. So if it is real, it will be marking it as score, like how real it is. So I am telling this how real it is, right? So this is called loss function. Based on the loss function, a discriminator will tell how close the particular generated images are close to the real images. So with the discriminator not only gets the generated data, but the real data it also will be getting to it. So how does a generator will generate data? I mean, I told that it will start from pixels, right? So how does it start? So even in a generator and discriminator, we have to create more models in the generator and discriminator itself. So how do we do it? Neural networks is the simplest answer. So the layers we have talked in the last session, convolutional layer, dense layers, sequential models, everything can be used in the generator and discriminator. So this is how the generator and discriminator works. So I had told in previous session that CNN used for detection, right? But not only for detection, but I mean classification. But it CNN can even generate images. But if we have more models to generate images, what is uniqueness about the each model? Now I'll be telling the uniqueness about CNN model while generating the images and GAN model. So CNN model learns data in particular layer about each in a little bit of features. Whereas coming to GAN, based on the neural network it has, a simplest GAN can learn all of the data in one layer. I mean, it is a time-taking process. Of course, it takes around months to train our image data. But coming to neural CNNs, the segmentation will be happening in the CNN, where the structure of the data will be there. It will be learning about the structure in the CNNs. If you like, let's say if you go for the medical image, the structure of the any brain or any body part, it needs to be there. Like let's say one body part has like a right side, one like a cerebellum or like that. The structure will be there in the CNNs, whereas GANs will be a global optimization, so it can randomize the things. So that is the backdrop of GAN. But there is a mixture of GANs and CNN, which is called unit GAN. So this is the mixture of unit GAN is a mixture of CNN and GAN. So this will perform the segmentation and the randomizing and the optimization of the global features on the um, data. So now, so what type of loss functions can a discriminator take? So there are many loss functions like gradient descent loss function, convoluted function, and one popular function is Euclidean distance. So this takes two images. Of course, the real image and the fake image will be sent into the discriminator, and then it performs the Euclidean distance pairwise. So here it takes each pixel and compares the each pixel. So based on this, and it will give you a score how close the particular generated image is to real image. So this is the training process of a GAN. So how much time can it take? And GAN needs a lot of data to train and to give the good results. Like if you take around like 1,000 images and you give it to GAN, it won't work properly because it need to learn features on its own. It's a deep learning model. So you won't be doing any pre-processing and doing any extraction of features here. If you do the extraction of features here, what GAN can't learn any of the GAN can't learn any of the generating images. Why is that? Because GAN is a deep learning model which need to learn on its own, where it need to learn on the features, how the structure is there, how the features are repeating on itself. Whereas if we do the extraction and give it to the GAN, and it will be just an overfitting neural network. And now let's see. Let's go deep into the GAN structure and learn about the particular GAN, which is progressive GAN. So in the recent times, progressive GAN has shown a lot of researchers in the particular times. And why is it? Any GAN can generate images. There are many types of GANs, DC GAN, Wasserstein GAN, and style GAN. Style GAN here is used for generating the people's images. If you want any face image, then you go for the style GAN. So each GAN has a specific uniqueness in them. So coming to progressive GAN, what is the uniqueness? So here you can start from just like 2x2 pixels itself. So like how CNN works in each layer, how the futures works, that is how that is how progressive GAN is also similar. But here it doesn't learn about some features, but it starts at the low dimensions. So here you can see the structure of the program. So here we have very few pixels, and then at 4x4 to become 8x8, and there is more pixels, and at the end you can see a face where it has more pixels. So this is how it progresses. So at one layer, it will be learning about the data, and it will be learned in the particular size. So it will be an easy process and not so time consuming. So this is how it learns all the features in at one dimensionality, and then sends the all of the feature to the next dimension and make it more learn. So this is how progressive can has its stability. So what type of loss functions progressive can take? So it can take any loss functions like gradient descent and Wasserstein Euclidean distance. So what in any recent times, anyone has any idea where progressive cans can be used? So especially when when you want the faster results, or when you want any image data to be more resoluted. So you guys now we will be seeing enhanced versions and enhancement in many apps. So how is it done? So it's not only done by taking pixel and just rearranging them into the more grid-like structure, but using GANs itself, the enhancement can take. So especially progressive GANs help in the enhancement. Okay, now let's see a simple code of the progressive GAN. So this code is done by PyTorch. So here you can see the factors, right? So these are the factors deciding like from how much dimension to how much dimension I have to go. So starting with the 1, here you can see 1 by 32. So that means an image by 32 will be starting whatever the resolution is by 32 by 32 of that pixel size. And these are the models which I have made. Here you can see a convolutional 2D. We have learned about the convolutional layer, right? Yesterday in last session in the neural network. This is the same convolutional network. So here pixel norm is there. So why do we use pixel norm? So I have told that dimensionality will be increased in the layers, right, and the GANs. So that is why we need the pixel norm, whether it is to change the dimension of a particular picture. So generator will be generating the images and will be sending to the discriminator, right? And discriminator have to reduce it to the particular dimensions. So that is why pixel norm will be used. And now let's see about the generator model. Now, how can we change? This is how I have made sending it to the input channels and image channels. So why did I kept here image channels as 3? That is because my image contains RGB colors. So that is how it is 3. And what are the Z dimensions is that number of classes. So this code was on architecture. So I had around 23 as dimension, and input channels are the each picture I'll be sending. So this is a sequential model, of course. So in the sequential model, there are many layers of the dense. So here you can see convolutional layers, ReLU layers, and again pixel norm, where we'll be changing the dimensionality. So, and after that, these are the functions we use for the increasing or decreasing of an image dimensions. So coming to discriminator, it needs to identify the loss function and then take the generated and the real images together. And then itself, it can identify, it can give the score, and that score will be going back to the generator, and generator will be trying to improve. And when does exactly the training process of this GAN stops? So now when the generator is successfully generated an image which is very similar to the real images, and then the discriminator doesn't even recognize between it if it is real or fake, then the model has reached its potential. That is how we stop the training process. And where exactly now progressive GANs the research has stopped? Like, I mean, what exactly the recent researchers were there? So in many domains, progressive GAN is has developed in in medical imaging, in self-learning cars, of course. Because why GAN is there? Because let's say we don't have any data. Let's get into medical data. So if we have a rare disease, we don't even have a particular data on it. So here progressive can take a lot of researches, and then it creates a new data. So it helps in many domains like this. So coming to Gen AI. So Gen AI has a lot of scope in upcoming fields, not only to like generate data or anything. You can see now that Gemini and Bard, ChatGPT have reached their a good amount of potential to create new data, but still it needs improving. So a lot of researchers in this particular topic will be more efficient.